Hello, so this question is minimum cost to hire a K worker. So this question is pretty tough. So you have two conditions. So first condition is every worker in the pay group has to pay at least their minimum wage. So what does at least mean? Less than or equal or more, right? So uh, and the second condition is in the group, each worker pay directly to their quality. So what's that mean? So the index 0, 70, and 10, the you're going to pay so proportionally, right? If you see proportionally, it's going to be a ratio. So for index 0, so it's going to be 10, 70, right? And then the ratio is 7. Index 1 is going to be 20 and 50. The ratio is going to be 5 over 2. Index 2 is going to be representing 30, comma 5. The ratio is 6. Based on the ratio, I know this guy um, is not, you know, it's not working harder than this one, right? Um, so if I want to hire with a K worker, I'm going to hire the first one and then the second one, right? But how do I get the answer 105? So here's the trick. So what you need to do is you want to add. Um, oh wait, I think this is 5. I think I swapped the orders. So 5 and 30, right? So again, all right, back to example 1. How do I get 105? So I know like for the ratio, if I use this ratio to pay this person, it's not valid, right? Because it has to be proportionally. So if I use 7 to pay the ratio 7 to pay with I equal to 2 the second worker, it's valid for sure because more, right? At least. So I'm using 7. 7 times what? So um so sum of the quality is 15, right? So based on the quality, I pay proportionally to the worker. So it's gonna be 15 right here, and then you will get 35, 7, so it's 105. So again, we want to keep the largest ratio in the end of the array. So it has to be sorted. So it's going to be smallest to largest for ratio. And then this will be what? This will consider a base ideal, right? And also we want to have another queue to sort the quality, which is the highest to, so quality, which is the highest to smallest. So the more highest quality you have, like literally, like you don't want it. Even like if we need to look at the ratio, right? So based on the ratio, and then if the quality is too high, like like it doesn't pay. I mean, it doesn't worth to pay the worker. So we have two lists. One is the smallest to largest, and another one is the largest to smallest. And then we will start adding the worker quality in here. And then once this is greater than k, so when we are keep on track how many worker we add, right? So once the size is greater than k, we literally just want to remove the items from the queue, and also we want to update our current sum quality so we can time the ratio correctly. So in this way, I'm going to create class worker, and this will result inequality wage and then double. This will be consider ratio and declare the constructor. So list out ratio is going to be 1D, so it's cast the value, so it's going to be wage divided by quality, and yeah. So once I have the workers, I'm going to know how many workers going to be wage.length or quality.length, right? And doesn't matter which one I use. And then I'm just want to assign my workers I equal to new workers, right? And then it's going to be quality first, and then wage afterward. So once I have initialized the workers, right? I want to sort it. So sort the workers array. So when I sort it, I need to sort based on the ratio, right? So smallest goes first. A dot ratio, B dot ratio. So the smallest ratio go first, and then once I have the smallest ratio go first, I'm literally, not trying to, get this person. I mean, I need to pay proportionally, right? The pay proportionally is a key, and I need to have a priority queue. Integer pq dot new priority queue, and this will return a minus. Sorry, this will return b minus a. The largest to smallest. In this one, we're going to technically add, the quality into the priority queue, and with the what, with the what's that called? The highest quality you want to exclude, and then you want to keep the lowest quality with the best, sorry, with the best ratio. So I'm gonna have a result about max return result, and then I'm going to say sum quality. So next is going to be traverse. So the sum quality will just keep adding. So once you add, just offer to the PQ. And at some moment, PQ.size is greater than K. You want to poll, and when you poll, you don't you no longer need the previous worker, right? So you want to minus equal the PQ.poll. So we add the worker quality into the PQ, and then when we pull, we subtract. So at some moment, the PQ size is going to be equal to K. At that moment, I want to find out the minimum, right? And then the minimum is going to be the ratio. So worker A ratio times the sum quality. So at this moment, so worker is sorted from smallest to largest. So at this moment, I know the current worker ratio is satisfied to pay proportionally to the previous one, for sure. So yeah, this will be a solution. Okay, so for the time and space, let's think about it. This is all of n, this is unlog n, and this is log n, and then this is all of n. So the time is going to be unlog n. This is all of n, I mean all of k, this one, and constant. So the worst case is going to be all of n. All right, so see you.